Hey guys, in this video I'm going to show you how to make a k-nearest neighbors regressor with using just Numpy, and also I'm going to show you how to create confidence bands around your predictions. So let's get started. So first I'm going to open up a terminal and I'm going to make a directory called KNN Regression. So let's cd to nearest, and then I'm going to open up VS Code. So the first thing I'm going to add is I'm going to add a init file. And then I'm going to add a test directory. And then again, in the test directory, I'll add a init. And then another directory called neighbors, if I can spell it. Neighbors, neighbors, and then there I'll add an init as well. Okay, so now we'll get started. On our neighbors, we're going to add our KNN.py, KNN regression.py. So on here, we're going to import Numpy, it's NP, and then we're going to call our class KNN regressor, and then we're going to have a initializer, and on our initializer we're going to set n initially equal to 30. So we're going to say self.n is equal to n, and then within this class we're also going to have a fit method, which is going to take an x and a y. We're going to say self.x equals to x, self.y is equal to y. And then we go and annotate these. nd array, numpy.nd array. Okay. So the next thing we need to do is I want to go on this neighbors and add another directory called utils. And in the non-utils, I'm going to have again another init file. And then I'll also have utils.py. So again, here we're going to import Numpy as np, and then I'm going to make a helper function here called make dataset. Actually, I'll call it make sinusoidal, and we'll give it a default size of 100 and a seed of 123. And I'll explain what this means here in a minute. So on here, we're going to use the seed to make a random number generator, random.randomState. And on here, we're going to set it to the seed. So again, we'll go and annotate these. These are both ints. And then this right here will return an numpy, that nd array. Actually, it's going to return a tuple of nd array numpy.nd array. And then we'll go and put these there. Okay. So the first thing I want to do is I want to make my x to be uniformly distributed. So I'm going to say RNG uniform. We're going to go from low is equal to 0, high equal to 1, and then the size is equal to our size. And then my y, actually I want to give it some error. So epsilon is going to be equal to RNG dot normal. And in fact, let's give epsilon to be a parameter to put in here. Eps, say float, and we'll set it equal to 0.2 for now. So it's going to be normally location of 0 and a scale of eps. And then we'll simply set y is equal to numpy.sign of 4x plus the eps. And then we'll return x and y. So on my neighbors, so I have my regression class, and then I generated a data set that will simulate some curve. So let's go to our test and sort of test this make sinusoid real quick. Test, we'll add, actually this was supposed to be here. It's supposed to be, oops. Move that there. Okay, let me see. Got my neighbors, utils here, KNN Regressor test. So we're in our test file, we're gonna add our test.py. So on here, I'm gonna say from neighbors.utils import make utils.tils import make a sinusoid. So we're going to have here called test sinusoidal. So let's just test the default here. So we'll say make sinusoidal. We'll leave it the default here. I'm going to say x and y are equal to this. Assert x.shape is equal to 100. And this needs to be a double equal sign since it's a logical statement. And then let's test this here, see if we can pass the test. Pytest. And I think it's because I'm in my poetry. Let's see, deactivate. Okay, Pytest. Let's see here. Okay, so I figured out what was going on here. I needed to rename this file test underscore whatever I was testing. Before I had test Perl, and Pytest will not pick that up. It needs to be test, not Perl. So continuing on, let's continue here. Let's test, see if we get it. And as you can see, we do not, because this is actually, the shape is actually returns a tuple and not a list. So let's just do this. And I need to put the comma afterwards to make it realize it's a tuple, and there we go, we passed that. We can do the same with y. And then we can also maybe assert x.mean minus 0.5 is the, let's see, the absolute of this guy. Since we know it's uniformly distributed, it should have an average of 0.5 more or less. So we'll say make sure it's, you know, less than 1/10 off of that. And again, we're passing, so that's good. And we can also do -VV for full, and we can see it passed. Okay, so we passed that test. So can't think of anything else we really need to test here. So let's go back to KNN regression. So we have our fit and our, so now we can maybe make a test for the fit. So we'll go find test fit. We need to import it, of course. So from neighbors, KNN regression, import our KNN regressor. So we'll have a KNN regressor. We'll give it, sure, an n is equal to 30. That's fine. Equal to 30. And then we'll do KNN fit, make a sinusoidal. X and Y are equal to make sinusoidal. And then we'll do KNN.fit X and Y. So what are we testing here? We want to assert KNN.x is equal to X. And then assert KNN.y is equal to Y. And this should hopefully pass. And we did not pass because the truth is ambiguous, because we need to use .all. So this is going to return a Numpy array of booleans, and what all will do is check that every single one of them is true. If any of them is false, it will return false, which is what we need. And again, we passed. So that's looking good there. So now we know we have our test and our data generator. So let's continue on here with our KNN regressor. So now into the meat of it, which is going to be predict, if I can spell it. So we need to give it a new x. So we'll call it x new. And this will be a numpy.nd array. We'll go with that. So how do we do this? So what we'll first want to do is we want to first get the distance. So we'll say, so actually, let's see, so we'll do, actually this will just be a float. No, we'll make a numpy array. ND. We just gotta be careful here with how we cast it. So we want to get x new minus self.x. But again, we need to be careful about the casting because the shape of this and this one may not necessarily be the same. So how do we want to do this? So what we'll probably want to do here is we want to reshape this guy to be one row minus 1 by 1, and we want x to be to only be 1 by minus 1. And so that way we should get a matrix of the right shape. And then once we have that, we want to square this, and this will be our distance. And so once we have our distance, we want to use distance.arg, and we need to tell it that this is an ND array. ND array. So distance dot, and we want to find arg partition by self dot n, and the axes we are going to want to do this by is by the first axes, because that's where our data is at. So, and then once we have that, this should be our args. And then we'll just simply want to return self.y at the args dot mean, and this will be along the axes of 1. So let's see if we can get this to work. So we'll go to test neighbors. And I'm just going to copy this over. So again, we're all doing the same thing, except we can remove these tests as that's already redundant. So we'll do, so again, let's import Numpy here. Import Numpy as NP. So we'll do x predict will be equal to numpy dot len space 0 to 1. We'll do it 100 times. So let's try that. So y predict will be equal to KNN dot predict x. So let's see, there's probably something that's not going to be right here, so let's just do assert y predict dot shape should be equal to 100 by 1. Okay, so we failed, so it's 100, which actually might be okay. So let's do that. And just to make sure, since they're both 100 data points, let's actually make this 200, just to verify that it's 200 actually. And we failed because it's 100. So we got an error here, so we must have got some indexing going on. So let's start to troubleshoot this. I'm going to just put a breakpoint right here. And let's see what we got here. Let's start debugging this. Let's give ourselves some space here. Okay, so here, let's see. We have our x new, and that's x new. Let's see, is that correct? Should be linearly. Oh, okay, that's why. Okay, so that may be the source of our error, but let us see if we can pass the test. Let me just delete this guy here. Let's see if that fixes it. And we pass. So far it looks like we're doing everything we need to. So let's see, what else can we test here? We'll come back to the test later. Let's just see if we can start making some plots and just seeing if we can actually visualize these results. So let's go back to our utils files and let's make a plot. Make a plot. Let's give it some data. X is an ND array. We'll give it our Y, which is again an ND array. Our X predict dot ND array, and we'll give it our Y predict, which is again an ND array. This will return none. And this should be a comma, and I think that looks correct. So let's get going. So first we're going to need to import matplotlib. Import matplotlib as plt. Oops, .pyplot as plt. So next, I'm not sure why it's not picking up that as a source. So let's see. Let's do plt dot. So let's do this. Plt dot figure subplots fig size equal to 12 by 6. So let's see, the first thing we want to do is a scatter plot of our X and Y. And then we'll do a just a normal plot of our X predict, Y predict. And then we'll just plt.show. Let's show it. Show our work. And then let's see, finally in our main folder, let us make a main.py. Now let's see if we can plot this. So I'm going to say from neighbors dot KNN regression dot import KNN regressor from neighbors dot KNN dot util. Oops, sorry, neighbors dot utils. Utils dot utils import. Make sinusoid and make a plot. Okay, so the first thing we'll do is get our data, as equal again, make sinusoidal. Next thing we want to do is KNN, make our regressor, KNN.fit X and Y. And then we'll want to X predict will be mp.linspace, and I'll probably need to import it for Numpy as an mp. Linspace from 0 to 1, give it 200 again, and then Y predict will be equal to KNN.predict X predict. And then let's make a plot of our X or Y, X predict, Y predict, and let's see if this works. So we'll do Python 3, and this is going to be our main.py. And we can see we've got something which appears to be sinusoidal, but we definitely got some issues here. For one, it doesn't appear to be too much, the epsilon doesn't really appear to be present, it appears to be almost perfectly sinusoidal. And then our KNN regressor appears to be just pretty much right at the average if I had to take a guess. So let's figure out what's going on here. So first things first, why is my epsilon not being added on to it? 4 times x plus EPS. Let me see, how big was the scale on there? Let's give it maybe a little bit more scale. Don't think that's what's causing it, but let's see here. EPS equal to 0. Let's make it like 1. Let's give it a lot of noise. Let's see if this generates a lot of noise. And no, it does not. Definitely does not generate noise. Okay. So let us see here. Is our... Oh, we should probably give our epsilon some size. Otherwise, it's just going to generate one number. Now let's see if that gives us a little bit. Yeah, now we got a lot of error. That's definitely what we're looking for. So we'll go back. Let's get rid of him. Let's just leave it again at the defaults and verify that we get something that looks... Okay, that looks good. Yes, that's definitely closer to what we're looking at. So the next thing we need to do is figure out what's going on with our regressor. Why is it just going right at the average? So to do that, let's go and try to debug our regressor. So again, let's just walk through this predict method here. Okay, so let's see, we'll go next. Let's see, so our distance, distance.shape should be 200 by 100. It is. Distance.max, oops. Max is 99, so that's pretty good. Min, pretty much close to 0, so that's looking pretty close. Let's see. Let's go next. So we got args, right? Okay, so this is definitely an issue. So for some reason, these should be these should definitely not be floating points. So we got something wrong here. So distance.arg partition. Well, let's just do it by 2. And I misspelled it. Partition by 2. Okay, so that looks correct. So what happened here? Our partition axes equals 1. Again, that's args. Interesting. Oh, I see, because args is going to be a special. Let me just print args. Let's see what that is. Okay, so that's why arguments is a special statement in the debugger. Let's see here. So self dot y at the args. So that should give us some numbers. And again, on the arguments, actually, we only want these up, including to self.n, and I think that's probably going to be our problem. Before this arg partition just puts everything to the kth to the left and everything greater than the kth to the right. So it basically still includes all the data set, just kind of reshuffles them around. So actually, we need to just only include up to the n. And I think that's going to fix our problem here. So let's get out of the debugger. And let's try running that again. Has no TN, and I need to spell correctly. Let's try that again. And again, this is going to be two-dimensional, so actually I think I need to do this. Let's see what that does. And that looks correct. So now we got something that's starting to look like a k nearest neighbors regressor. So I think the next thing I want to do, I think I want to make this line a little bit thicker, and then let's change up the color since it's the same color as the dots. So let's just go and clean up the that right there real quick. So we our plot. Let's make the color. Let's make it green, and then we'll make the line width equal to 2. Let's see what that does. Maybe a little bit thicker. Maybe just a little bit thicker. Let's try 3. Just to give it a little pop. Okay, and that looks pretty good. And so let's just go on here and see if maybe we can, let's actually see if we can change up our parameters here. So let's go back to the main. And actually our regressor, let's see, let's actually just give it n equals to 5 and see what we get. Okay, yeah, so we see we're starting to get a lot more sort of variance going on here with our fit, which is what we would expect. So it looks like it's working out reasonably well. But let's just go and run maybe a few more tests just to make sure we're dotting our I's and checking our T's. So again, I'm going to call it test trivial. And actually, let's just copy all that over. Yeah, so let's just copy this over. KNN regressor except on here. Let's just do 100. Fit. Do him 100. Predict. So let's just assert that the prediction.mean is just simply equal to y.mean. So if we set it equal to, so if we set n equals to basically every single point in the data set, our regressor should just do the mean. And we did not pass. Let's actually do the, let's see. Args are out of bounds. So actually, let's see, up to n. So that may actually need to be n minus 1, if I'm not mistaken. Let's try n, actually. Let's see here, utils. Let's go to KNN Regression. Let's debug this here. Let's figure out what's going on. Dist.shape. So if I do distance at all up to 100, that works. See, next, args, here up to, oops, print args up to here, up to 100, right? So that works. go back to our test. What's going on here? Oh, I think that's because this one actually... Okay, so this should actually be grand mean, y mean, predict. Let's actually mark this and only run this test. At pytest.mark.run me. Okay, let's see. So we'll import Pytest. Pytest here. Run me. Okay, so let's see. Distance, so we got distance, shape, we got a 100 by 100 here. So let's see. Next, print args. Args is not defined, so yep, we got that error. Let's go back here. Okay, so let's see. We have our test, KNN regression here. So we have our distance.arg partition self.n axes equals 1 arg partition value is out of bounds. So this should actually be self, so that should actually be self.n minus 1. So let's see if that solves our issue here. Get rid of the breakpoint. And let's see. And it looks like we passed. So it looks like that caught the bug that we were looking for. So I'm trying to think if there's any other tests we can kind of do before we move on with generating the confidence intervals. Let's just make sure everything else wasn't affected by that change we just made. So let's run all the tests. And yep, it looks like we are good there. Everything is passing. Okay. So let's get started with, I think we can go ahead and get started with the confidence intervals. So let's go back to our KNN, and actually I should probably annotate these a little bit more. So this doesn't return anything. And this guy right here is going to return a ND array. Boom. Okay, so we'll do predict underscore with confidence self, and again we're going to do the same as the other prediction. We're going to give it an x new, which is going to be an ND array, and this guy is actually going to return a tuple of 3 ND arrays. So the first one is going to be the prediction we already have. The next one will be the lower confidence interval. And the last one will be the upper confidence interval. So I think that will do. Before we get started with this method though, let's actually put our confidence that we want. And by default, I'll just do 5%. And I guess just to be good here, we'll just return, make sure the init returns none. And let's see, self.cConfidence will just be equal to CONF, so that should take care of that. And this should be lowercase. Okay, so first thing we need to do here is we need to Actually, I'm going to set the seed right here. Seed equals 1, 2, 3. This will also be an int. Self.seed is equal to seed. So the first thing we need to do here is we need to make some random permutations of our data. What we're going to do here is I'm going to take my, make a random number generator, random state, random state, and give it our self.seed. So I'm going to make my permutations here. So let's do rng.choice. Let's see, our samples is equal to self.y.shape at 0. That's how many samples we have. So we want to do a choice of our samples. The size is equal to our samples. And then replace is by default true, but let's explicitly call it out as true here so others know when they're looking at it that we are indeed replacing, choosing with replacing. So this right here should give us a permutation. Actually, let's give it how many simulations we want to do. That should actually be a parameter of our confidence interval. Let's just do simulations. And by default, let's just give it 1,000 simulations. And again, this should be an int. Okay. So this should actually be how many simulations we want by samples. So our so what we're going to do now is I'm just going to go and start looping through this. So I'm going to put actually first let's get the prediction. So we'll just do self.predict x new is equal to x new. That's passed into here. Y predict. Let's go with that. So first we'll just go and just call this method that we already defined here, since we know we need to return that. The next thing we want to do, let's just go jump into a for loop here for our simulations. So for IDX and range of our simulations, we actually need to get our confidence intervals. Y predicts, or Y, I'm going to call this Y CONF for confidence interval. It's going to be P.0, and it's going to be our number of simulations by how many samples we have. So I'm going to say Y at our confidence at IDX is going to be equal to, and actually I should get our permutation actually out of this loop. Permutation, and actually let's make this to enumerate. And instead of here, this should be our permutation. So we'll loop through each permutation. So we'll say the Y CONF IDX is going to be self.predict our x new. And actually I can't just use predict again. I need to actually make the permutation. So actually we can't, yeah, we'll just need to do, we'll have to fix it up here. So let's see. So again, we got to do again our distance metric. So our distance np.nd array, and I'll probably go back and refactor this just because I'm reusing a lot of code that I wasn't anticipating. is going to be our x new dot reshape minus 1 by 1 minus self dot x at our permutation that we're using. And then again, we're going to reshape him at 1 by minus 1 and square him. So there's that. Again, we got to do our args are equal to the distance dot arg partition. Self.n doesn't change. And then again, we're going to want to go up to self.n. And then once we're there, we're going to say y at CNF at idx is equal to self.y at permutation let's see. We'll say our y here is equal to self.y at the permutation, just to make sure there's no conflict. And then we'll say y CNF again at idx. This is the simulation number we're on. Is equal to y at args self.y at args dot mean axes is equal to 1. And then we want our confidence to be equal to numpy dot quantile. It's going to be for our y confidence interval, and then our q is going to be equal to in a list. The first one will be our confidence self.conf divided by 2, and then we'll do 100 minus self.confidence over 2. And this needs to be along the first axis, not the 0th. And we will return a tuple with y predict, confidence 0, confidence 1. And I think that should hopefully get us what we're looking for. Let's see, let's go and make a test and see if we got kind of the shape right here. Where's our test file? Right here. Yankin word. Let's see, we're going to do this guy here. So we'll do the same data set we've been working on before. And so instead of here, I'm actually going to call y predict confidence. Y predict, and let's see, this will be lower and upper. So let's see if we can do this. Assert lower dot shape is equal to, this should be 100. So let's see if we get an error. So let's run Pytest. And yep, we got an error. So let's figure out what's going on here. Has no attribute reshap. So we made a spelling mistake. Let's see. Mean reshape. Oops. Reshape. Okay. Let's see, let's try that again. Let's see here, what's wrong here? Quantiles must be in the range Okay, so it's actually the wrong method. This should actually be percentile is actually what I was meaning to do. So let's try percentile. Let's see here. We failed again because it's 1,000. Let's see. So we must have did it along. Oh, okay, so we did it along the long axis. This should actually be the 0th axis. That's actually our simulation axis. That's what we want the percentiles on. And that passed. Okay, so I think let's go back to our test and make sure actually this works out here. So we'll do lower. Let's do upper dot shape. Should be the same, but just to make sure. And we can actually just do the same for Y predict. So let's just make sure they're all the same shape and look correct. So they all look correct. So the last thing we need to do here is let's go back to our utility file and let's see if we can plot the confidence interval. So we'll do fill between. Again, we'll use our X predict. So Y1 will be our upper. So we'll just do, actually I probably need to, I need to find that as an argument first. And let's actually clean this up because this is getting to be quite busy right here. Okay, so we'll do our lower, again, as an np.nd array, and our upper, which is an np.nd array. So we'll do lower and upper. So I think that's all we need to do here. Actually, let's make the color green. So let's make it match the line color. And then we'll want to not cover up our line, our predicted line. So let's just give it an alpha of 0.3, just to make it lightly shaded. So let's go back to our main file. And so now our plot is missing those last two parameters, so let's get them. So actually I don't really need this anymore because now my other method pretty much takes care of that. So Y predict, lower and upper. We'll just say KNN.predict confidence, X predict. So let's see, let's go here and then we'll add them in. So we'll add our lower and our upper. And let's see what we get. So we'll run Python 3 main.py. And they cannot be broadcast. Interesting. So we didn't have an issue there. One space. Yeah, we definitely got an error here. Let's actually see if the 100 fixes it. And of course it does. So we see we got some confidence intervals. But as you can see, we still got a bug here. I had to change that to 100. That actually shouldn't be the case. So I must have hard coded something somewhere incorrectly. So let's figure out what's going on there. So let's make this error again. And it looks like line 26, predict confidence. So let's go check that guy out. Line 26. So let's see, how did we get a casting type error here? Self.y, a permutation, x new shape, reshape, arg partition. So let's see, what did we do here? Six Y IDX cannot broadcast from shape into shape. Y confidence is 0, samples sims. Y.shape. Okay, so this actually needs to be not the samples, but xnew.shape at 0. And let's see if that fixes our error. And it appears it fixes our error. And so actually, let's see if we can fit maybe a little bit smoother looking line. Again, we'd probably want to do some cross validation on this. But let's just do KNN with, and let me get on the right file here. So let's just do a KNN with 10 neighbors. That seemed like it was pretty good before. And that was not what I meant to do. So 10 neighbors. And there you can see we got the data, the prediction, which is the dark green line, and we got a confidence interval of our predicted line. And yeah, so I think the last thing I want to do is let's fix up the labeling maybe a little bit on the plot again. So we'll just say, let's see, on this one we'll call this our data. We'll make this guy label equal to, so this is going to be the expected value of x given, oopsie, not x, y given x, or really our approximation. And then the fill between will be our, we'll call this our confidence interval. Confidence interval. And AX legend. Location, we'll put it on the lower right. And I think that's how you do that. Let's see if it's happy with that. Label, and it's got an unexpected. Oh, that's because that's not where I meant to put that. That should actually be on the scatter plot. Is equal to data. And symbol found there. So did not like that, probably because it needs to be this. Exit out of this guy. Let's try that again. And there we go. Let's blow this up. And so there you can see pretty much that's our k nearest neighbors regressor. We got the prediction. We saw how to do that entirely using Numpy, and we were able to generate a confidence interval of our prediction, again using just Numpy and just doing some random permutations of our data. So that's all I have for you guys. I know this one is a little bit longer. I'm trying to make it more of a code along and less edited and more raw, so let me know if you like it. And also kind of doing some more software engineering type of stuff versus the normal Jupyter Notebook setup. So leave a like, comment, and subscribe if you enjoy the material, and I'll see you guys next time.